Welcome to this presentation on the instrumentation and instrument systems found in the SF-260 aircraft. We'll be covering an overview of their components, functions, and how they contribute to safe and efficient flight operations. Engine indicating system. First up, let's talk about the engine indicating system. This system provides crucial information about the engine's performance, allowing pilots to monitor its health and operation. It includes several key indicators: cylinder temperature indicator, oil temperature indicator, manifold pressure indicator, tachometer indicator, oil pressure indicator, fuel flow indicator. Engine indicating system. This diagram shows the different components of the engine indicating system. It's important to know the location and function of each component to properly monitor the engine's performance. Moving on to fuel, the engine fuel indicating system provides pilots with vital information about fuel pressure and fuel flow. Fuel pressure gauge. This image illustrates the fuel pressure gauge and transducer, which are critical components for monitoring the fuel system. It also highlights the connection to the 28 VDC essential busbar. Engine oil system. Next, we have the engine oil system, which is essential for ensuring proper lubrication and cooling of the engine. The oil temperature and oil pressure indicators are vital for monitoring the system's health. This image illustrates how the oil temperature and oil pressure readings are displayed in the cockpit. It also highlights the connection to the 28 VDC essential busbar. Engine instrument markings. Understanding the engine instrument markings is crucial for interpreting the health and operational status of the engine at a glance. Image, engine instrument markings. This diagram gives an overview of what the markings mean. Each section corresponds to a specific instrument, including cylinder head temperature, oil pressure, fuel pressure, tachometer, and carburetor air temperature, airflow indicator. Each instrument includes a visual representation, along with detailed information on color-coded markings, red, yellow, and green zones, and their corresponding numerical values and operating ranges. Flight Environment Data System. Now let's move on to the Flight Environment Data System, which provides critical information about the aircraft's flight environment. This system heavily relies on the pitot-static system. The pitot-static system is a pressure-based system that measures airspeed, altitude, and vertical speed. Pitot-static system. This image shows the components of the pitot-static system, including the airspeed indicator, altimeter, and vertical speed indicator. It also shows the connections between the pitot tube, static ports, and these instruments. Airspeed indicator. The airspeed indicator displays the speed of the aircraft relative to the surrounding air. It operates by measuring the difference between static pressure from the static port and total pressure, also called pitot pressure, from the pitot tube. This relationship can be expressed by the equation, total equal to static plus dynamic. Altimeter. The altimeter indicates the aircraft's altitude above a given pressure level. It works by measuring static pressure. The altimeter uses an aneroid capsule that expands and contracts with changes in static pressure. This movement is then translated into an altitude reading on the gauge. Vertical speed indicator, VSI. The vertical speed indicator, VSI, also known as the variometer, shows the rate at which an aircraft is climbing or descending. The VSI measures the rate of change of static pressure. It uses a calibrated leak to provide a delayed pressure reading, which is then compared to the instantaneous static pressure to determine the rate of climb or descent. Attitude and direction system. The attitude and direction system provides essential information about the aircraft's orientation and direction. This includes the attitude indicator and the turn and slip indicator. Attitude indicator. The attitude indicator, also known as the artificial horizon, displays the aircraft's pitch and roll attitude relative to the horizon. This image highlights the key components of the attitude indicator, such as the bank index, off flag, horizon display, and pitch trim knob. The 28 VDC essential busbar is also noted. Turn and slip indicator. The turn and slip indicator displays the rate of turn and the coordination of the aircraft, helping pilots maintain a coordinated flight. This image provides a detailed view of the turn and slip indicator, including the turn indicator, slip indicator, and the 28 VDC essential busbar connection. Miscellaneous instruments. Beyond the core systems, there are also miscellaneous instruments that provide additional information to the pilot. These instruments include chronometer, accelerometer, outside air temperature sensor, and indicator. This image shows various miscellaneous instruments found in the cockpit. Electronic flight instrument system. Modern aircraft often feature advanced electronic systems. Let's look at some in the SF-260. Garmin G5. The Garmin G5 is an electronic flight instrument display that is highly versatile. It can function as a primary or backup attitude indicator, as well as a DG directional gyro or HSI horizontal situation indicator. It can also display air data such as airspeed, altitude, and vertical speed. In the event of a power loss, an optional battery backup can sustain the G5 flight display for up to 4 hours, ensuring continued critical information. This image displays the Garmin G5 electronic flight instrument. TAS 1000 system. The TAS 1000 system is another advanced system. It includes an air data and fuel computer, a wind indicator display, fuel flow sensors, and an air temperature sensor. TAS 1000 panel mounted air data and fuel computer. This computer processes data from various sensors to provide accurate flight information. Wind indicator display. The wind indicator graphically displays winds aloft, head, tail wind, and drift angle. The wind indicator continuously displays actual wind aloft data for the aircraft's current altitude, including wind direction, head, tail wind component, and wind drift angle. The TAS 1000 system provides a comprehensive array of data, as seen in this table. Thank you for joining this overview of the SF-260's instrumentation and instrument systems. Understanding these systems is key to safe and effective flight operations.